very much. All right. For that kind introduction, it's a real pleasure to be here. I was telling Edith earlier that I was born in Gainesville and my parents attended U of F. And so U of F has a very tender place in my heart. But enough about me. I'm going to talk about today about understanding how language experience influences language use. And I'm going to start off with a couple of sentences just to give you a sense of what I mean when I talk about language use. So imagine, for whatever reason, you wanted to say a sentence like this: the secretary who the senator who the reporter disliked attacked went to the Capitol, right? So this is a really complicated sentence. When I give this talk to psychologists, this kind of blows their mind more, but you know, you're all linguists here, and so you understand that this is a triply nested structure, right? It's really difficult. And just by changing the order of the words, we can get the same semantic meaning out of it, right? The reporter disliked the senator who attacked the secretary who went to the Capitol, but it's not nearly as difficult. And so the question I'm interested in is, how does our everyday experience with language impact our ability to process difficult sentences like this one on the top? Okay. Before I go further, I just want to say, if you have any questions, feel free to jump in the middle, either in the chat or just kind of butt in. So I'm going to focus on language exposure. So what's the link between language exposure and sentence processing? And in particular, I'm interested in how our digital media habits, specifically what we read on the internet, how does that affect our grammatical processing skill? And I'm going to talk more about this towards the end of this talk. But you know, imagine you're the kind of person who reads the Wall Street Journal or the New York Times for an hour each day. So you're reading a certain amount of time, right? And the kind of language that you're going to be exposed to is going to be different than someone who is reading TMZ or ESPN every day, right? And no shade to TMZ or ESPN. I enjoy reading these publications, but they're different in terms of their relative complexity. So the Wall Street Journal is written at a college level, basically. TMZ and ESPN is written at around an 8th grade level. And so just the complexity of the grammar that you're being exposed to is going to be different. And so I'm interested in, does that difference influence or change our skill in grammatical processing? So we know that exposure has some kind of influence on processing, right? And this kind of has to be true. Otherwise, we wouldn't learn a language, right? So a kid who grows up in Tokyo is very likely to grow up speaking Japanese. I grew up in Gainesville, so I'm very likely to grow up learning English. And that's due to my exposure to the language. A more controversial question is, does the exposure that we experience as an adult influence our language use? And there's a bunch of evidence suggesting that, yeah, it probably does in a lot of different ways, right? So there's constraint-based theories showing that we're exquisitely sensitive to the statistics of language, and that impacts processing. And so if this is true, this is relevant to a lot of folks, right? It's relevant to linguists who are interested in the structure of language, educators. I'm in a college of education, and so my colleagues who are teaching are really interested in the kinds of language you can expose someone to teach them a new language, teach them academic language, and so on. And it's also relevant to clinicians and computer scientists. So we know language exposure influences language use, but there's limits to it, right? And I don't need to tell y'all this, because you know that, oh, sorry, before I get there, I want to just show you an example of the fact that language exposure influences language processing. So if you take a sentence like the elementary students protested, the sentence could continue with the uniforms, right, which is a noun. That'd be a perfectly fine sentence. But it could also continue with a clause: the uniforms were too uncomfortable. And so at the point of uniforms, you don't know whether the sentence is going to end or whether you're at the subject of an embedded clause, right? And it turns out certain verbs like to have certain types of complements or arguments follow them. So for example, protested is a verb that likes to have direct objects follow it. There are other verbs like suspected that also are totally fine occurring with a direct object like the outcome, or a sentential complement like the outcome had been staged. But unlike protested, suspected most often occurs with a sentential complement. And so we're sensitive to this because if you get a direct object verb like protested, we know that people expect it to be followed by a direct object, because if it's not, they slow down a little bit, all right? So it's a very subtle effect, but it suggests that we're sensitive to really sort of fine-grained information in the linguistic signal. Now, what I was going to say before was that we know that there's limits to this exposure, right? And so this is a graph from Johnson and Newport that I'm sure many of you know very well. It's a graph on the y-axis here. We have English proficiency, and on the x-axis, we have age of arrival of immigrants to the United States. And, you know, this is a well-known effect. The earlier the age of arrival, the more proficient English is in the population. And so, interestingly, these folks out here who arrived relatively late, they're being exposed to lots of language too, right? But there seems to be something of a ceiling in terms of, and more variability in the eventual outcome. So there's this puzzle, right? So we're really sensitive to the statistics of language. So, and exposure to language is central to learning and using it, but there seem to be limits. And so what I'm interested in is sort of probing those limits and better understanding what those constraints are. Okay, so what I'm going to talk to you today about is testing this theory of what I'll call the exposure account. So the exposure account is basically things that we're exposed to are easier to process. So things that are more frequent are easier to process. And I'm going to look at this in two different contexts. One, in an hour-long experimental session where we give people a complex sentence and see if they get better at processing it. So this is adaptation. And then we're going to look at exposure in everyday life. And this is where sort of looking at people's reading habits and digital media consumption are going to come into play. Okay, so let's talk about exposure in an hour-long session. Okay, so the critical sentences are these sentences here. The experienced soldiers warned about the dangers before the midnight raid, versus the experienced soldiers warned about the dangers conducted the midnight raid. So I often garden path myself every time I read the sentence, even though I've read these sentences for many years. So this top sentence is a lot easier, right? Because when you get to warned, you believe that you've encountered the main verb of the sentence and you turn out to be correct. And the sentence goes off without a hitch. In the second sentence, the experienced soldiers warned about the dangers conducted the midnight raid. Here, you think warned is the main verb, but it turns out not to be. It turns out to be the verb within a reduced relative clause. Okay, and so you experience some difficulty when you get to conducted. You're like, what's going on? You got to revise your representation, and then you sort of go on with your life. But the point is that people in general find these sentences more difficult than these sentences. Okay. All right. Okay. So the exposure account predicts that the difficulty that we experience with that hard sentence is basically due to our experience with the language. So that reduced relative complex sentence is comparatively rare compared to, you know, your regular old subject verb object sentence in English. But one version of the exposure account is that basically we rapidly update our expectations in any given context. And so if you're exposed to a lot of these difficult sentences, then over time, the sentence is going to be easier to process. You're going to be better at predicting that that sentence is coming up. You shouldn't experience that boggle. And on the flip side, that sentence that was once easy should now become difficult, right? Because it's become less expected and less predictable. All right. So things that are frequent should be easy to process. Things that are infrequent should be more difficult to process. And Jaeger and colleagues found that Florian Jaeger, Alex Fine, and colleagues found that people seem to adapt pretty quickly. So within one experimental session, if you give subjects a hard sentence, they're going to have an easier time reading it over time. Okay, and so this was very exciting to me personally. I think in the field, this idea that we're so malleable. And so in my lab, we sort of set out to run a bunch of adaptation experiments, particularly in the area of prosody, which I'm not talking about prosody today, but I was really interested in seeing whether people could learn to predict prosody that didn't correspond with syntax, prosody from non-native speakers, and we were also interested in syntactic adaptation across contexts. And the short story is that none of these adaptation experiments we ran worked, like none of them. So this was the work of my former student, Ariel James, who's now a professor at Macalester College, Kiva Harrington-Stack, who's a postdoc here in computer science at Vanderbilt now, and Alex Fine, who was an author on the previous work, and was doing a postdoc with me at the time. And so this was really kind of frustrating, right? You run all these studies, none of them work, and so Alex had done work on the original study, and so we thought, okay, what we'll do is we'll replicate that study to just kind of get a sense of what the effect size we're dealing with looks like, and once we get that, we'll know maybe how like how many subjects we should be running, like what we need to do to increase the power for all these studies that didn't work. Okay, so that was our plan. And so to do this replication, we used a self-paced reading task. And if you haven't seen one self-paced reading moving windows experiment, basically we measure the reading times of a sentence one word at a time. It's thought to be a measure of in-the-moment processing. So you get a glimpse into sort of where in the sentence people are experiencing difficulty. It's kind of approximates normal reading, not really, but it's somewhat natural. It's doable, right? So it looks something like this. This is an example of a moving window sentence, right? And so you can see that as you press the space bar or whatever, one word appears at a time and then disappears when the next word comes up. And after that sentence appears, a question comes up, and then you have to answer the question, yes or no. And usually the question is about the sentence itself, so it serves as a second measure. Okay, so in the original Fine and Jaeger study, this was back in 2013, they ran 80 participants, and they gave people these reduced relatives. So these are the hard sentences coded in red, and these main verb sentences coded in blue here. And the general idea was that you expose subjects to a lot of these difficult sentences and see if their reading times, the garden path effect goes down over time. Okay, so they had an experimental group, and first phase out of 3 phases, they gave people a bunch of these hard sentences, right? And then in the second phase, they give them more hard sentences, but this is where they wanted to evaluate whether processing the sentences got easier. Okay, so this is the test phase. And then in a third test phase, they gave them the easy sentences. And the prediction here is that these easy sentences, main verb sentences, should now be hard. They're less predictable in the context, right? Because you've gotten a bunch of these relative clauses, okay? So there should be a reduction in difficulty in phase 1 to phase 2, and then more difficulty in phase 3. And they compare this to a control condition where in phase 1, instead of getting these reduced relatives, they were just given random filler sentences. So that allowed them to compare difficulty in phase 2 across the conditions. And the prediction is that the control group should experience more difficulty than the experimental group. And then the opposite effect in phase 3, where the control group should have an easier time with these main verb sentences than the experimental group. All right, so there's a lot of comparisons here, but that's sort of the gist. And so we attempted to replicate this. They ran their experiment online, and we did as well. But first, we wanted to do a power analysis to see, given the results they got, how many subjects we have to run in order to get the same result. And we had 3 different models for the 3 different crucial effects, but I'm only showing 2 here, but okay. You can see just by sort of eyeballing these, in order to get like 90% power, so this is comparing that third block across control and experimental, you'd need to have to run around 400 subjects with the number of items they had. And we decided, I mean, that's a lot of subjects. It's expensive, right, to run 400 subjects. And so we decided we would double the number of items, and doubling, oh, sorry, I had that backwards. So at 90% power, with the number of items they ran, you'd have to run 640 subjects. And so we doubled the number of items to bring that number down. Okay, so still a lot of subjects to run, but we wanted to be sure that we got the effect. So we ran a same study with 481 participants. This was on Mechanical Turk, double the number of items. And we used the same design. Now I'm going to show you the data that we got. And the effects, the critical effects here are going to be a comparison of the ambiguous versions of these sentences to the unambiguous versions, right? So that gives us a measure of how much difficulty they experienced when they got the ambiguous sentence, how much they garden path, okay? Okay, so for this first comparison, looking to see the extent to which the experimental group had a decrease in difficulty from reading these more complex ambiguous sentences, we see that in our experimental group here, there was a significant decrease. So there was an interaction here where the difference between ambiguous and unambiguous sentences in the first block actually was reduced in the second block, okay? So overall, people were faster in block 2, the block 1, but the effect, the amount of difficulty they experienced was smaller in block 2 compared to block 1. So we replicated that effect. Interestingly, when we compare the experimental group to the control group in phase 2, we don't see an interaction. And in fact, the filler first is a little bit slower than like our control group is a little bit slower than the experimental group, but the size of the effect is about the same. There's no significant interaction. And so what that means is that this effect that we saw initially may not have been due to adaptation. It may be just having to do something to do with just, you know, moving windows is kind of a weird task, and maybe people just get faster at it over time, and that squashes the effect. That's sort of our hypothesis, because we don't get a difference between experimental and control group. And in comparing the experimental control in phase 3, where they're getting these main verb sentences, again, you can see there's like 0 difference between the control and the experimental. So their experience with these sentences is exactly the same. So this was kind of disappointing, right? Like running 450, 460 subjects to replicate a study, and we didn't see any kind of effect. So we finished that study and sort of concluded that, you know, we didn't really find much evidence in short intervals for adaptation. You know, it's a null result, right? And because it's a null result, we have to interpret it with caution. Like, I'm great at getting null results. They can happen because there's no effect, or they could happen because you ran kind of a terrible experiment. And so it's always hard to know. But we had enough power that I think if there was an effect there, we probably would have seen it. And we used the exact same method as Jaeger's group. But it turns out it's very hard to publish a null result. So we wrote this up and kind of explained what we did, included the power analysis, and sent it to 2 different journals, and they just got desk rejected. There's like one journal is like, well, we didn't publish this first one, and we just don't want to get involved with this. We didn't publish the Jaeger, so they just didn't want to get involved. A second journal that I won't name, but I'm an associate editor there now, basically desk rejected us and said, well, the first study, I can't believe the first study got published. So why would anyone be interested in knowing that it didn't replicate, right? So that was frustrating. But eventually we did get it published in Memory and Cognition, and my student Kiva won the Article of the Year prize for the paper, right? But I just sort of share that story to let you know that, you know, we should all be replicating studies, but it can be a challenge to get them published, all right? And after our study was published, work from Kyle Christensen's lab came out showing a very similar lack of an effect. Work by Grusha Prasad and Tal Linson found that you can get adaptation, but the effects are really small. They ran many hundreds of subjects to find effects. And I know Edith has looked at questions of adaptation in both L1 and L2 language. And so it looks like if there are effects of adaptation within short time periods, they're really small. Okay. So this, just sort of taking a step back and going back to this puzzle, you know, we know language exposure matters, but it doesn't seem to happen quickly. And so this leads us to the question of, well, over what time frame does exposure to language influence language processing? And so we've sort of zoomed out and look at day-to-day exposure to language to see what kind of effects it has on processing. And so the big question I'm going to sort of shift to now is understanding whether exposure to more complex grammatical structure in everyday life, is it linked to grammatical processing, right? And we can look at this using an individual differences approach. And this is linked to sort of broader questions, I think, in cognitive science about how you think language is fundamentally structured and represented. So there are folks who argue that linguistic structure is guided by rules and variables and constrained by cognitive limits, right? Like there's these abstract representations for language that are more rule-based. And on the other hand, you have folks that argue that linguistic knowledge is more statistical, maybe in something like a distributed neural network. And so in thinking about individual differences in how language is processed, it's sort of intimately related to those two ways of thinking about language, right? So if you think language is more rule and variable governed, then those folks tend to argue that, you know, things like working memory and attention are going to be relevant to language processing. If you think language processing is statistical, say you're like Mary Ellen McDonald, you're going to think that exposure to language is going to matter quite a bit, right? And so the goal of our study was to really take a bunch of these individual difference measures for constructs people have argued are important for language processing, and then see which ones reign supreme, right? Like, can we use these constructs as a way to sort of think about how language is represented? Okay, so on the left hand here are sort of folks who have argued that that sort of more cognitive factors can predict individual differences. Have looked at things like working memory, inhibitory control, processing speed. Folks that argue that language exposure, predictability matter, look at things like language experience, print exposure, and phonological ability. So in this study, and just a reference real quick, this is work by Ariel James, Scott Frondorf, Eunyoung Lee, and myself. We took 133 participants. This was in person, not on Amazon Turk. And we had them do the same kind of self-paced reading experiments. And we looked at a bunch of different individual difference constructs: language experience, phonological ability, working memory capacity, inhibitory control, and perceptual speed. And all of our subjects were undergrads at the University of Illinois. Okay, and so we actually looked at 3 different types of syntactic structures. I like to think of them as the greatest hits in psycholinguistics. Like these are the kind of sentences people look at. I'm only going to talk about one today. You can look at the paper for what happens with the other ones, but basically similar findings. So we looked at subject versus object relative clauses. So like the lawyer who liked the senator was charged with conspiracy versus the lawyer who the senator liked was charged with conspiracy. So this first relative clause is a subject relative because the noun it modifies is the subject of the relative clause. And this one's an object relative because lawyer here is the object of the relative clause, right? It's the person being liked, okay? And so generally object relatives are harder. People take longer to read them than subject relatives for lots of interesting theoretical reasons that I won't go into really for the sake of time. But the question we're interested in is which individual difference factors predict the size of the difference between object versus subject relatives, okay? So we gave our participants these subject relatives to read in self-paced reading. On the y-axis is the residualized reading time for each of these word regions on the x-axis. And you can see that we get what everyone else gets, right? Like object relatives in orange here. People slow down over the relative clause compared to subject relatives here in blue, right? So overall, aggregated across our population, we get the effect. People generally find object relatives to be more difficult. We also asked them questions about the sentence. And so on the y-axis here, we have question accuracy, and we get a main effect where object relative accuracy is lower than subject relative accuracy. And interestingly, if we ask a question, if we ask a question about the relative clause, their performance is lower, and it's even more lower, that's a phrase, in the object relative compared to the subject relative. Okay, so there's a significant interaction there. Okay, so this is just the population effects. The interesting thing are the individual differences. And we gave them a whole battery of individual difference tasks. So in order to measure language experience, we gave subjects the author recognition test. And so basically in this task, you're presented with a name and you have to say whether it's a real author or not. And so here, the answer is no, this is not an author. It kind of looks like Terry Pratchett, but it's not. And so this correlates with reading. We gave people the North American Adult Reading Test. So if you call this epitome, that's wrong. If you call it epitome, it's right. We gave folks a vocabulary test, a comparative reading habits where we asked them how much they read compared to other people like them. And then we asked them to estimate their total reading time. So we used all of these measures as a way to get a score for their language experience. Okay. We have a bunch of other constructs, and I'm not going to go through them because I don't want you to fall asleep. It's right after lunch. I do want to talk a little bit about working memory. We gave subjects the reading span, listening span, and operation span task. So basically in this task, in the reading span task, you give people a sentence, and then they have to answer true or false, and then you give them a letter that they have to remember, and then you give them another sentence, and they have to answer a question, and another letter, and then at random points, they have to recall the letters that they had to remember up to that point. Subjects hate this task. It's hard. I have low working memory, and it's only gotten worse as I've gotten older. But we had this for listening span, and we had a digital math version as well. Okay. We also had several different measures of inhibitory control, and we had a couple of measures for perceptual speed. Okay. All right. So we had a lot of measures. This experiment took 3 hours across 2 sessions. And so now I'm going to show you the results. So here are 5 different constructs. And for our online measure, actually, we didn't get good reliability for differences between object and subject relatives. We did get good reliability just for reading time per word, and we found that that correlated with phonological ability. But interestingly, the reliability was just horrible for that object versus subject relative difference. And if you have low reliability, you're not going to find it correlating with anything. So that was sort of interesting because there have been lots of work up to what we've done showing that I guess I'll say people don't typically report reliability. So it's hard to know how to interpret results when it's not reported. For our accuracy data, we found that both language experience and working memory predicted were correlated with higher accuracy. Okay, so it looks like both language exposure and working memory capacity predict people's ultimate comprehension, like what they actually get out of the sentence. And the online question, we'll hold on to that for just a second. Okay, so there's higher language experience scores predict better comprehension question accuracy. I got to show at least one scatter plot since it's individual differences, and clearly I've shown the best one here. So on the y-axis is accuracy, on the x-axis is our composite language experience score from all those measures, and you can see a linear correlation here. Okay, so we can conclude that language exposure in everyday life is linked to comprehension. Perhaps it influences comprehension and grammatical skill, but not online grammatical processing. And this last question about sort of online processing is something that we continue to be interested in. And so we're running a follow-up study now that I'll talk about briefly. This is with Michelle Perdomo, who is a proud alum of U of Linguistics at Florida. My current student, Ainsley Potter, and Van Listeralde, who's also a postdoc. And we thought that, maybe one of the reasons we got such low reliability for subject versus object relative clauses was because we looked just at a college population. So it could be a restricted range problem where there just, wasn't enough variability in grammatical skill to see a correlation. And also maybe our sample size was too low. So in this study, we ran 200 subjects, and this was during the pandemic. And so we're like, okay, let's do this online. So that allowed us to have more participants and a more diverse sample. And so again, just to quickly show you in this follow-up study, y-axis, we have reading times. On the x-axis are our word regions. And again, we see object relatives here in blue are read more slowly than the subject relatives in orange. And this time we see a correlation between language experience and the size of the object subject difficulty effect. Okay, so on the y-axis here, we have reaction time. And on the x-axis here, we have the total number of hours subjects report reading. This orange line here is the object relative clause, and the blue line here is the subject relative clause condition. And you can see that fewer numbers of hours read equal sort of to a bigger object subject difficulty, and then over time, that difference disappears. The more the subject reads, the smaller that difference is. Okay, so this is hardening here. We're still working on sort of calculating the reliability of this effect, but the fact that we see a significant interaction between our conditions and the total hours read is suggestive. Okay, so for our next steps, we're interested in, and this is something that's going on right now, people's digital media. So is it just like sort of the quantity of language that you're exposed to, or does the language type actually matter? And so we're looking at this in 10 to 15-year-old adolescents, and we're getting measures of what they read, how often they read. We're also looking at this in adults. This is Michelle's work. And we've started using some natural language processing tools to maybe do a slightly more sophisticated measure of sort of text properties. Okay, and so this is something that Michelle has been working on. So she did her dissertation on looking at verb particles, right? You can either say she put down the book versus she put the book down, right? So that particle down can occur either after the direct object or before it. And there's a host of different factors that seem to be related to speaker's choice, right? And whether they want to produce a continuous verb particle versus a discontinuous verb object particle. So people are more likely to produce the verb particle construction when the direct object's really long, when it's new, when it's an indefinite, and when it is highly idiomatic. And so in order to look at the relationship between text quality or text features and people's choice in this construction, we asked subjects we just basically asked them, like, which of these constructions would you use? And we also asked them, what are the top 5 websites you visit most frequently? And so people put things like Reddit, Twitter, NPR, like all the websites you might imagine. And we took these websites, we told them not to include like email or like social media that we couldn't access. And we ran them through a couple of NLP toolkits that Scott Crossley and his group at Georgia State have developed. So there's the TACO, which provides indices that give information about discourse cohesion, the TALS or TAILS that gives information about lexical sophistication, and this task measure that gives information about syntactic complexity. All right. And so we get all of these indices for these websites. We go to the websites, we scrape them for content, we run them through these tools, and then we run a principal component analysis to see how those indices clump together. And when we do that, we get a number of components that sort of roughly map on to various lexical, syntactic, and discourse properties of the text. And then we include those components in a model and use those to predict the choice of construction for a given reader, okay? And again, this is pilot data, but what we see is that there are properties of the text that map on to people's choices for how they produce verb particles, okay? And so for example, frequency here, the frequency of the lexical frequency of words in digital content means that it's more likely an individual is to use discontinuous in these idiomatic versus literal condition. I didn't talk about that condition difference, but critically, there seems to be a relationship between these various pieces of text and people's syntactic choices. So our next step is to apply the same kind of analysis to our questions about online processing. And so far the data looks promising, but it's not quite there yet to present. But it raises this interesting possibility that what you read every day is going to be related to how much complexity you're going to experience when you encounter a difficult sentence. And I'm going to hedge a little bit and say that there's just a link because we don't quite know whether the websites you read are causing you to have more or less difficulty reading a sentence, or if there's some third factor where, you know, if you're a person who's maybe skilled with grammatical processing, you're going to experience less difficulty on the sentences, but maybe you seek out certain types of text to read. I have to say I'm a little skeptical of that. Let me put it this way. I think whether a person reads ESPN and TMZ is probably not a function of their grammatical processing skill, but that's something that we're going to have to look at and explore. Okay, so we've looked at these predictions under two different contexts. The predictions of this exposure account, where exposure to difficult sentences should make things easier or harder for readers and listeners. We didn't find strong evidence in an hour-long session. But we have seen some evidence that exposure in everyday life seems to influence language comprehension skills. So we may be sensitive to linguistic distributions, but maybe it takes a lot to move the needle in terms of changing listener predictions and language processing skills. You know, there's theories out there that all aspects of linguistic structure can be primed through exposure to the environment, but maybe some aspects of language are less adaptable to this than other aspects of language. So we found that things like prosodic boundaries don't really seem to prime very easily. If you give people a bunch of boundaries in a given location, it doesn't influence where they're likely to produce intonational boundaries. But in contrast, if we prime someone with speech rate, then they're quite easily primed to speak more quickly or more slowly, depending on what they've been exposed to. So maybe these differences in how exposure influences language use can tell us something about how the system is structured and where to carve it at the joints. So going back to our original puzzle, exposure to language seems to be central to learning language and using language, but there are limits, and we're working on trying to figure out what those limits are. All right, thank you for listening. Okay. Questions?
That was a great talk.